In a time where wearing masks has become an essential part of our lives, we are beginning to realize the value of fresh, clean air. Imagine a world where there is no clean air to breathe. That is what will happen if we continue to use conventional energy sources. We cannot live without energy, but we can find alternative and better methods to harvest and utilize energy. Today, we are going to talk about such a method. A very good day to all of you who are joining with us from around the world. I'm your host, Jayada Disanayake from IEEE Student Branch of University of Moratuwa. I warmly welcome you all to the first Tech Talk brought to you by the IEEE Power Electronics Society Student Branch Chapter of University of Moratuwa in collaboration with IESL Young Members Section and Department of Electrical Engineering of University of Moratuwa. The topic of the Tech Talk 1.0 is residential microgrids of the future today. What are residential microgrids? How do they provide efficient, low-cost, and clean energy, all the while enhancing local resiliency? I know all of you are eagerly waiting to find out answers. But before that, I would like to remind our audience to keep your microphones muted during the session. To avoid any disturbances, you will be given the opportunity to ask questions during the Q&A session. First and foremost, in order to welcome you all, I cordially invite the Chapter Advisor of IEEE Power Electronics Society Student Branch Chapter of University of Moratuwa, Professor Udayanga Hemapala. Over to you, sir.
Thank you, Jayada. Good evening, everyone. I am Udayanga Hemapala, the Head of Electrical Engineering Department, University of Moratuwa. As the advisor of IEEE Power Electronics Society Student Branch Chapter of University of Moratuwa, Sri Lanka, it is my pleasure to welcome for the very first Tech Talk on residential microgrid for the future and today. First and foremost, I would like to welcome a remarkable character for this occasion. He would be the guest speaker for today's Tech Talk, and I would be warmly welcoming Mr. A.J. Perkins, President of Instant ON and former President of DR, Microgrid LLC and USA. If I am to provide little insight about this great personality, I would like to say that he is an advisor of California Energy Alliance and has worked at Lockheed Martin Energy and several other organizations for years of experience in the field. Mr. Perkins, we are proud to have you here and waiting to be inspired by your thoughts. On behalf of the organizing team, I would like to thank IESL Young Members Section and the Department of Electrical Engineering, University of Moratuwa for their support in this regard. Dear participants, I am thankful for your presence today and welcome you all. Thank you. It's over to you, Jayada.
Thank you very much, sir, for your constant support and encouragement. Now, it is the moment you've all been waiting for. As Professor Hemapala mentioned, our guest speaker for today is an outstanding personality who has vast experience and knowledge in the field of power and energy. Not only he serves as the president of Instant On and former president of DR Microgrid LLC, he is also an award-winning motivational speaker, entrepreneur, and a celebrated leadership trainer. Mr. A.J. Perkins, it is a great privilege to have you here with us today. Over to you, sir.
Thank you so much. I am going to share my screen. Can we see my screen? Residential microgrids of the future today?
Yes, so we can see.
Thank you so much. Well, aloha everyone. As a native Hawaiian born and raised in the islands, in the middle of the Pacific, 2,500 miles away from the nearest landmass I know a thing or two about resiliency and sustainability. Prior to COVID-19, I traveled to the United States speaking at conferences and convinced as a subject matter expert on microgrids. I spoke about how to use microgrids as a source of not just resiliency, utility cost savings, and carbon reduction, but through supporting the grid, I also showed how you would be able to create a revenue stream as well. The funny thing is that because of COVID, I now have spoken all around the world without leaving my home here in California. This is a great pleasure for me to be able to speak with all of you. My typical audience is usually comprised of CEOs, business executives, financiers, engineers, and salespeople. Being able to speak with all of you today, it's exciting for me because you are the ones looking to enter our world, and I'm excited to see what all of you will come up with next. And why this is so important to me, residential microgrids of the future today, is because some of the things that we are experiencing in the microgrid world are unprecedented. So we need forward-thinking individuals and engineers to be able to help us tackle some of the challenges that we're dealing with. So as I get into this, I'd like to kind of set the stage with a story. It's a true story, and it's something that's going on, actively as of this morning as well. So back in October of 2020, about 3 months ago, I remember that I was in a very similar situation. I was presenting, it was 7 o'clock in the morning, and I was presenting to Credit Suisse and their financier partners from all around the world. And as I was presenting to them, I could see in the corner of my eye, my cell phone just bleeping because of onslaught of text messages that I was receiving from a group chat that consisted of my 2 brothers and all of our wives. And the thing that was really, interesting is that it just kept coming the whole time. So I finished my presentation. It was now a little after 8 o'clock, and I looked at my phone. And the first part of the message was from my wife. Now, my wife is a nurse, and she was at the hospital at that day, working. And usually when she's at the hospital, she's not real interactive because she's working. But she was the one that was engaged the most. And her first text to my family was, "Are you evacuating?" So apparently a wildfire had started the night before. At 6 o'clock in the morning, there was 100 acres that were burned. By 7 o'clock that morning, when I first started my presentation, there was over 1,000 acres that were burned. 2 blocks away from my brother's home, everything had been ordered to evacuate. Luckily, my brother and his family and their homes were safe and everything was well. But the reality of these wildfires coming so close to our family's home was a real big scenario for us, because it really showed how close this danger can come. Now, the reason why this is important is because as a Hawaiian growing up in the islands, we only worried about hurricanes and tsunamis. Wildfires were not a big deal. In California, wildfires, they had wildfire season. Now California is experiencing where wildfire season is a year-long event. It just continues to happen. And what recently started to happen was the utilities were granted permission to shut off the power grid to preempt and stop the spread of wildfires. So imagine this, you are in your home, the wildfire can be hundreds of miles away, nowhere near your home, nowhere near endangering your home, but because of the utility's ability to shut off the grid, your power is now off. The utilities do this to be able to prevent the spread of wildfires and to protect the community. But this ability to do this has also exposed some deficiencies within the community. You have families that need this power because of medication that needs to be refrigerated. You've got people that have breathing machines. You've got people that sleep with CPAP machines because they have sleep apnea. So you've got some of these deficiencies within the community that become exposed in a very, very quick manner. And we needed to figure out how to get power. So it also prompted us to look at all the other things that were spurring on the requests for microgrids and nanogrids in homes. Is now with COVID in our faces, more and more families working from remote locations, working from home. What we have learned is that there's a lot of people that are running multi-million-dollar businesses from their home. Now, that's really nice because they're close with their families, they get to spend time with their families. But the challenge there is if you're at home running your business and they shut off the power, you are in a really difficult situation because now it's not just safety for your families, but now your business that you've been operating out of your home because of COVID is now in jeopardy. Some of these outages have gone just hours. They've gone on for multi-day. In fact, just this morning, there was an area here in Southern California, Edison, that their power is not expected to be turned on for another 2 days. So this has really created some challenges for many of us. Now, many of you guys may think to yourselves, well, this is great, AJ, don't you think that's good that you'll be able to create this scenario? Now, let me ask you this. With this story that I just told you, imagine, I want you all to just think real quick. Imagine that you work with us and you have just been asked to design and help us build 1,000 nanogrids. 1,000 nanogrids, because I just told you the challenges that these communities are facing. So you go ahead and design a nanogrid. A nanogrid, like a microgrid, it requires a few different things to make it such. Number one, it requires generation. So say you decide to put solar panels up on the roof. Now you also need storage, something to store it. So now you've got battery storage in the garage. And then the most important thing, you need controls to be able to control load as well as to disconnect from the grid. So an automatic transfer switch, an ATS. So that allows us to disconnect our power supply from the grid, because if it's a downed power line and linemen are out fixing the lines, they don't want the power in your home to backfeed into the grid, and it could potentially harm somebody that's working on the grid. So that's why we put in this ATS to be able to stop the backflow of power. Now imagine again, you have designed microgrids to help overcome these challenges that I just told you about, the public safety power shutoffs, the blackouts, all these things. So now you feel good that you have protected these families, don't you? I know I would. Knowing that we've put in so many microgrids and nanogrids around the state makes me feel really good about myself, because I did help families. I protected the families from these challenges. But now let me ask you this. Here is a headline that came out in September 21st of 2020.
Excuse me, sir. Sorry to interrupt.
Yes.
The slides are in the presenter view. It would be nice if you can present them in the slideshow view.
Let me see. I'm sorry. Let me see. I don't know why this is happening. I apologize.
No, sir, no. That's fine.
Thank you so much. Let's see what we can do here. Stop share. Current slide. Is that better?
Now it's perfect, sir. Thank you. Thank you.
Beautiful. Thank you so much. technology. So again, as I was saying, when we look at, this is a real headline that came out on Microgrid Knowledge. And if you haven't seen Microgrid Knowledge has the largest database of white papers on microgrids in the world. So the news that comes out is all microgrid related, and this particular headline came out. And one of the things that happened is, again, now imagine if you have just installed all of these microgrids and nanogrids across the state, you're helping all of these families. And as you see here, one of the things that happened because of the wildfires, we started to show some deficiencies in solar production. So we had solar systems that typically put out 40 kWh of power a day in the summertime. And because of the smoke blocking the sun, these systems were now barely eking out 1.65 kWh per day. We had a system that was, that originally was supposed to be putting out 46 kWh per day because of the way we designed it. But because of the smoke blocking the sun and the soot from the smoke and embers floating in the air, and it was sitting on top of the solar panels, their solar system barely peaked out at 12 watts. That's barely enough to power one LED light bulb, let alone take care of an entire house, right? So when we talk about this, we're talking about how you have done all this work as an engineer to design these systems. And this is where we were in, literally. This article was written because of the challenges that we were facing. They called us up to say, can you tell us what problems you're facing? We want to be able to share with everybody because we think that this is something that's happening throughout, just nobody talks about it. So we were happy to tell everybody about it. But now imagine if you were the one that designed these systems, what would you do? You have families investing $20, $30, $50,000 US in these systems to protect their families. And now because of smoke, because of soot sitting on top of their solar panels, they cannot even turn on a light bulb with all of this equipment that was put in. So that's why when I talk about the microgrids of the future here today, that's why it's so important. It's because we need you to help figure out what some of these challenges could be and then figure out ways to avoid them. So when I ask you with your problem-solving minds, what would you do if you were faced, if you had 1,000 systems out there and now the smoke is blocking out the sun, the soot is covering the solar panels, what would you do to allow these families to be able to restore power and get the power that they need? Well, some people say, you know what, I would go ahead and I would go ahead and start cleaning the solar panels, right? That sounds like the natural thing to do. So you go ahead and you decide that you want to clean the solar panels, and now you go ahead and create a different set of problems. Okay, I don't know if you guys ever have searched this, but if you ever search on the internet solar panel cleaning, I can guarantee you 95 to 99% of the pictures that you will see are in broad daylight. Now, there's a challenge with that. For anybody that understands this, the temperature of a solar panel in the middle of the day is 20 to 40 degrees higher than the ambient temperature, which means in California, the temperature of these solar panels can be in excess of 140, 150 degrees. Okay, so now you've got these solar panels that are 140, 150 degrees, and you decide to go and clean them in the middle of the day, and you put cold water on these very hot solar panels. Some of these solar panels are going to be in jeopardy of cracking. It could ruin the system because of your thoughts on, let me go ahead and clean this and make it better. So the other thing that people don't realize is that you now have a situation where, okay, the soot has sat on my solar panels for so long that I cannot just shoot water on it. So I would go get a brush and try to clean it off. The problem with that is you go ahead and get a brush to clean off the soot and the debris. you now could potentially harm the system and void the warranties. So the things that we think about, we haven't thought all the way through them, and we now create bigger problems because now our 30-year solar warranty could be void because I used cleaning products, I used a brush on my solar panels, which you're not supposed to use. So this really puts us in a situation where we have to really be innovative in how we design and think about these systems staying up, okay? So now luckily, we were able to find a solution that came from the agricultural world. RST Technology, RST Cleantech, they took technology from the agriculture world and put it into our world to be able to put sprinklers on every solar panel. Now, it was really great because of the way that it happened. And as you can see, it allows us to be able to clean every solar panel, but more importantly, we can actually program it so that it can clean at night when the solar panels are not 150 degrees. We can also do it remotely. So we can set it on a timer to be able to clean once every few days. Now, the thing is that when people clean their solar panels, they'll usually hire a company to do it once a year, maybe twice a year, maybe even every quarter. Here in California, once my solar panels are clean, within 4 to 5 days, it starts to get dust and debris on it. It starts to get dirty. So the efficiency of my microgrid starts to decrease within 5 to 7 days. So by being able to program this to work every week, every other day for all we care. Now, this is where the ingenuity starts to come in, okay? So this is their system. Traditionally, they would go ahead and allow, again, the control box is connected to the water spigot. From there, it goes up onto the roof, and every single solar panel has sprinklers. What we've done is, because of the wildfire scenario, we've taken it a step further. We said, if we can go ahead and put sprinklers on top of the solar panels, could we go ahead and run it the entire length of the roof? Why would we do that? Because when wildfires come in, homes do not always catch fire because of fire coming directly up to their homes. They usually catch fire because the embers float. They can float for miles and then sit on a home and then eventually sometimes spark those fires that can eventually damage these properties. So what we did was we said, instead of having families go out, and believe me, this is a real picture. This is what you see, where people are out there trying to protect their homes. And again, when we talk about microgrids, guys, it's not just the engineering part of it all, it's protecting families. That's the ultimate goal, is protecting families, businesses, and communities. So as we're out here looking at this picture, we're thinking, oh my gosh, imagine if I can do something better. Yes, you can. Because now we actually have a case study in which we utilize this technology to clean our solar panels. Originally, that's what the whole purpose was. But we knew what we needed to do to help prevent these fires from catching on. And in this particular case, as you can see, the building on the right was completely demolished. They had no clean tech on it. But on the left side, the building not only withstood its all of the issues with the wildfire around, but it also was able to keep the solar panels clean. So it's a small little thing, but it allows us to be able to think outside of the box. You guys, as new engineers coming into our world, you need to be able to think beyond just solar, battery storage, and controls. Those things are necessary, but sometimes we need to figure out, how do we bring in new opportunities because of the challenges that we're being faced with right now. So now let me show you the actual real headline for this particular article. Because this addresses, on one side, you may say, AJ, you addressed the soot sitting on the solar panels, but you didn't address the smoke that was blocking out the sun. Well, we did, because we knew we had to. So now if you see, this is actually the true headline from that particular article. And now you see that we started to delve into applying fuel cell technology to our residential solar microgrid. Okay, so when we look at this was a real big opportunity, because fuel cells give us the ability to create power off of natural gas, renewable natural gas, propane, biodiesel, and hydrogen. In our case, we just utilized a natural gas fuel cell. So now I have a 1.5 kW fuel cell that is able to go in, and it's a micro CHP fuel cell. This particular one is a BG15 from Solid Power, Blue Gen. And what we have been able to do is integrate. This right here is a live installation of the first BlueGen fuel cell installed in a residential application here in the United States. So we have solar outside, we have a 10 kWh battery, and now we also have a 1.5 kW fuel cell. This particular fuel cell will put out the equivalent of a 7 kW solar system. Okay, so the good part about this fuel cell is, unlike solar that only produces power when the sun is out, my fuel cell can actually continue to produce power 24 hours. And ideally, that's what we would like it to do, is once it goes on, it just continues to create the power that we need within the home. But with this particular, system, it's a micro CHP. So it's combined heat and power. So what we see here is our BlueGen creates the input is the gas supply that comes in. And in this case, we're using natural gas. It provides electricity to the home, but we're also able to capture the heat and allow us to use that heat to create hot water for the home. So as a free byproduct of this fuel cell, we're able to create hot water for the home. So I give you this because now, again, it continues to create forward thinking as it relates to building and designing of these microgrids, okay? So we're able to take this fuel cell technology and a few things happen. We have a contract to build nanogrids in 1 million homes for the United States veterans. In our original design, when we secured the contract a little over a year ago, we originally secured the contract with the idea to put solar. We were going to put 5 kWh of solar on the roof and 40 kWh of batteries in the homes. That's equivalent to 3 or 4 Tesla Powerwalls. And then we were going to put a control system to be able to control all of this. Now, obviously, for those of you that are thinking about this, a 40 kWh battery in a home is kind of overkill. For a standard single family home here in the United States, we could probably get away with 1 or 2 Tesla Powerwalls. But the reason why we put in so much battery storage is because we were going to make sure that there was power security for a long period of time for these homes. But more importantly, when the power wasn't being used for the homes, we were actually selling it back to the utility so that we can create a revenue stream for the community. So why not put it in? The people are there to install. Why go ahead and put 10 kWh when I can put 40 kWh for a smaller amount? So this was a real big opportunity for us to really push the bounds and test what we were looking towards, okay? So here we now bring in this fuel cell, and some of the things that we've learned is now that we have the fuel cell that is creating power 24/7, it actually allows us to reduce the size of the battery. Because of this added ability to create power and generate power on site, we don't need such a large battery system. So right now the batteries are really expensive, right? So that's been the challenge, to be able to get solar plus storage in so many homes here in the United States, and I think across the world. So imagine now, instead of us having to pay for 40 kWh of batteries, we now have the ability to re-engineer it so that we use a much smaller battery. And more importantly, on top of the added resiliency from the microgrid, we've actually brought in redundancy, because we've got power from solar, we've got power from our fuel cell, and we've got stored power in our battery storage system. So now I take you to another scenario in which we've had to figure out different solutions. We have a 10 kWh portable battery, and this originally was designed for the RV market, right? The recreational vehicles, these mobile homes that would go. And this was a 10 kWh battery that can be charged in any, regular outlet, and then you can use it to plug into your RV or whatnot. And it really is a plug and play battery that almost creates your own microgrid. Okay, so that was a really interesting thing for us. But what we didn't realize is that when we secured a contract with a senior community, there were 15,000 homes. It was an all-electric community, and it was great to be able to have this community that was all electric, no natural gas into the community except for in the commercial buildings. So now they were being affected by these public safety power shutoffs, and now they wanted a microgrid. But the problem was the community association would not allow solar on the homes. They didn't want it because the way they built the homes, they were concerned that the weight of the solar panels were too much. They didn't want the aesthetics and the way that it looked. So we needed to figure out how to help them avoid these power outages because, again, this is the most vulnerable part of our community, seniors. So they needed power and they didn't have the ability to generate power. We can't put solar on their homes, and there's no natural gas inside of the homes either. So we couldn't put fuel cells or anything inside of the homes to generate power. We could put a battery, especially if the battery was, something like this where it was portable. But the problem is we needed a source to charge it. So what we did was we put in a 10 kWh portable battery in every single home. And we also went ahead and created a solar farm. And at their community center, we put in CHP, natural gas combined heat and power. So these 120 kW CHP systems would not only produce power, but they would also give us free hot water to be able to heat the pool at the community center. And more importantly, in the event of a power outage, we could go ahead and create an environment that was what we call the safe haven. A place where people could come, that the power would be on, and they could create a safe haven for people to be at. So what this did for us is it allowed us to be able to have these charging stations. So here in the US, we have, these propane tanks that we use for barbecues, and you can actually go down to the local gas station or hardware store and swap out these propane tanks. We took the same approach as we did these batteries. What we can do now is these families can now have the battery in their home and use them throughout the days when the power is on to help reduce their utility costs. Charge it at night when the power is cheap and dispatch it during the day when power is expensive. But what we also found is in the event of a power outage, we now have an essential loads panel. On every single one of their homes, our panels have an essential loads where only the essential loads are on. Because if I took a 10 kWh battery and powered the entire home, it would deplete pretty quickly. But now with an essential loads panel, some of them I've got the refrigerators on there, a garage door opener, some plugs, and some lights. So only the essential loads are backed up, so it allows the battery to last longer. Once the battery is depleted, they can now, just like the propane tank scenario, they can now bring the battery down to the community center and take a new freshly charged battery, and now they have this power in their homes. So I give you these examples because I want you to be able to think outside of the box. Again, designing microgrids is not just putting solar and storage and controls on a home. Because of the challenges that we're facing right now, it creates so many other challenges that it's our responsibility, it's your responsibility to think beyond just a simple microgrid. Right? So I'd like to take it another step further as we continue to think about it's no longer just microgrids, it's protecting families and communities, right? If we think with those terms in our mind, how do we protect families and communities? Creating power resiliency is just, as we built this million home nanogrid system, we started to look at not just the ability to keep the power on, but we also started to ask the question, when these power outages go on for an extended period of time, another thing that becomes vulnerable is your water supply. So what we've done is we've actually started, we actually integrated an atmospheric water generator. So what this does is this actually gives us the ability to create water out of air. So we plug it into our microgrid, and now what happens is it'll produce between 16 and 20 gallons of water per day. So this gives us the ability to protect these families in a very unique way. I give you guys these examples because that's what we're looking for. I'm telling you, speaking to you as somebody that's in the industry, I don't need engineers to just come up with different ways to put solar, battery storage, and controls on a home. I'm looking for people that can really understand how do we to these families in times of need. That's why microgrids are so important. That's why they're becoming prevalent. Everybody has seen, I mean, they're talking about the microgrid market here in the US in the billions and trillions over the next 5 to 10 years. And I believe it. I see it. I'm in the middle of it all, right? This is an example of an incident on home that shows all the various things that we have come up with to help make things better. It's important for us to look at this and say, this is how we continue to move the bar on how we build microgrids and nanogrids. We continue to ask the question, why are people asking for microgrids? And these are the three main reasons, right? I want to be green. I want to be able to reduce my carbon emissions. I want to be good for the planet. I'm tired of my high utility bills. They want to reduce their utility costs. Here in California, our utility costs for on a residential, anywhere from 14 to 22 cents per kWh. We're the second highest utility cost in the nation, right behind Hawaii. So the two places where I live are the two most expensive power bills. So being able to create a lower cost of electricity is really important for us as well, right? When I utilize and integrate fuel cells into my microgrid system, here in California, the retail price on being able to integrate gas into a fuel cell system is between 5 and 7 cents per kWh. The other part about that for us is that in California and other parts of the United States, they have time of use billing. Between the hours of 4 and 9 p.m., the power, this is how bad it gets. The power costs on a commercial facility normally between 3 and 5 cents per kWh. They're big power users. During the times of demand charges and high use periods between 4 and 9 p.m., the power costs are $22 to $25 per kWh. The disparity is so huge. So our ability to bring in these microgrids to not just protect from power shutoffs, but also to be able to protect and create these abilities to use your own power, your own on-site power to help reduce your energy costs are really, really big, right? So more and more people are finding that we can utilize these microgrids. And then again, the biggest reason is I cannot have my power shut off. I personally have sleep apnea. I sleep with a sleep apnea machine, a CPAP machine. If the power ever shuts off, I don't wake up in the morning. That's how bad this is. So when we talk about designing these microgrids, our work is very much in line with protecting life, including that of my own and my family. So it's necessary for us to think about this. So I'm going to take this a step further. I talked to you guys about these three reasons. And in the beginning, I said one of the other things that I talk about a lot is creating revenue. So it's not just renewable reduction and resiliency, but this is the most talked about scenario by utilizing microgrids. So I wrote 3 patents 2 years ago on how to utilize a microgrid to respond to demand response. So demand response here in the United States is when the power grid is being utilized too much. So in the middle of July, in summer, when it's 110 degrees here in California and everybody's air conditioners are on, it strains the grid. The power cannot be handled in terms of how much people are needing the power. So what happens is they actually reach out to these demand response customers, and they actually ask these customers to reduce their load. And what they do is, so if you've got 5 elevators in your building, you shut off 2 elevators. If you've got rooms that aren't being used, you shut off the lighting in those rooms. If you have 10, package unit air conditioners up on your roof, then you shut off 3 of them. So there are different ways in which you reduce your usage. And that's where curtailment comes in, where they ask you to curtail. The problem with curtailment is that it creates disruption in the way that my building operates, right? So for me personally, we had a building that we were part of a demand response program, and this was years ago, and we would get paid for reducing our load during these times of heavy use, which was great because, free money just for shutting off things. But the problem is they would shut off some of our air conditioners, and I'd have engineers in my office, $100, $200, $500 an hour that I'm paying these engineers, and they start sweating because it's uncomfortable, because they shut off my air conditioner in this home. It's 110 degrees outside. We cannot be dealing with this heat. So we opt out of demand response. We don't get the full revenue stream that we were hoping for. The utility doesn't get the full power that they needed. So it's a really bad scenario. So what we did was we created a scenario where you use microgrids to respond to demand response. So when they call a demand response event, I actually employ my microgrid to island the entire building. Why not? That's what the microgrid was designed for, right? So we islanded the entire building, which means a few things happen. Number one, I get the full maximum value for revenue because I took my entire building offline. Number two, there's no disruption. Because the microgrid is actively working, I have no disruption in my building at all. And number three, the utility gets the maximum load from us because of the reduction, because we employed the use of this microgrid. Now, take that a different step, okay? So that was our ability to utilize microgrids to support the grid, and that was a full offset scenario. We actually went a step further and said, what if there was a negative load reduction? So we have properties where, they may be a 500 kW max load on the building, but we put a 2 megawatt battery on their yard. We did that because some of these facilities needed that backup power because they could have no blip in their power. So we have these large battery systems. So now imagine if they call a demand response event, if I island the entire building, that's 500 kW that I get credited for, the revenue stream. But imagine I've got a 2 megawatt battery. Can I go ahead and nominate 1 megawatt? Now the challenge was, how do you credit 1 megawatt of power to a building that only has a max load of 500 kW. So the policy is still trying to work through that nuance here in the United States, but that's a real opportunity. Wouldn't you agree? I've got 2 megawatts sitting idle. Why couldn't you use it, right? So then the third scenario in which we wrote this patent was excess supply. So some of you may know in California, we produce too much electricity because of our renewables, to the point where they actually curtail renewables in California. And the more gross point is that they actually pay other states to take our excess. You can look online and you'll see article after article that talks about how California produces too much renewables, and we actually pay Arizona millions of dollars to take our excess power. Now, why would they do that? Well, because originally they reached out to Arizona and said, hey, we got too much power. Would you like it? And Arizona says, no, we don't need it. We've got our own power. Well, can you please take it because we have too much? We sat there and said, that's just ridiculous. So Arizona said, no, we won't take it, but if you pay us, we'll take it. And believe it or not, California said yes. California is paying Arizona to take their excess. California is curtailing renewables because we have too much renewables. And for any of you guys that know, California also instituted a mandate that all brand new homes have to have solar. So we already have a problem of excess renewable energy in California, and it's just going to get exacerbated. It's going to get even worse, okay? So now we worked with a pilot with PG&E for excess supply. So what that means is in those times of too much renewables being generated, instead of them paying Arizona, they actually pay us, but their version is to turn on equipment. So demand response is usually they pay you for curtailing or shutting off equipment. The flip side of that is excess supply. So whenever there's too much supply, they'll actually pay businesses to turn on equipment. But again, that's still disruption. If I'm not supposed to schedule this big piece of equipment to turn on until later, you're making me turn it on earlier. Yeah, I see the revenue, but again, it creates disruption. Demand response in all of its forms is usually disruption. Now, what we've done is we've created a scenario with utilizing our microgrid, because these are day event notices. They let you know a day ahead that they're going to need you to turn on equipment, which is good. But what we've done is we said, okay, because I know that they're going to do this tomorrow, instead of me putting my solar and all of my renewables into my battery, I deplete my battery. So come tomorrow, when they go ahead and call that event, I literally have an empty battery sitting there waiting to take all of this power. So now my microgrid has been able to earn revenue by discharging and by receiving as well. And that's the type of innovation that I want you guys to think about. I need you guys to be able to think, how can I create better scenarios? Guys, this patent was written by a native Hawaiian who was born and raised in the islands. I do not have the foresight and ingenuity to think, all of this stuff needs to be done. I haven't been in the industry for 30 or 40 years, but I thought about the things and the challenges associated with some of these, the events surrounding the use of microgrids, and that's what we created. We're the only ones doing this. Nobody else in the United States are doing these type of opportunities, utilizing microgrids in such a unique manner. So I'm coming to you and I'm looking at this saying, guys, we need help, right? We need ingenuity, right? The quality of being clever, original, and inventive, but we also need innovation, right? Creativity is thinking of good things. Innovation is doing good things. We need people to create things, but we also need people to just do it. And more importantly, we need teamwork, right? As Henry Ford said, is if everyone is moving forward together, then success takes care of itself, right? In my native tongue, we have a saying called pupukahi I holomua. And what that means is together, we all move forward. And that's what I'm looking for. Is I'm looking for all of you that have been on this call to be able to think, what is it that I can do within this industry? Right? When we think about residential microgrids of the future, we need it today. But because you guys are coming into this world, I need you also to think about what is tomorrow, what is possible, what is necessary, right? Because as you can see in this picture, this is a real picture. Believe it or not, this wealthy gentleman went ahead and created his own island so that he could sustain himself. He sat there and said, I need to show everybody what is possible. The sad part about it is he did this for himself. Success in life has really little to do with what you gain in life or what you accomplish, but it has more to do with what you do for others. So I look to all of you to figure out what it is that we can do. Take the education, the experience, the knowledge that you can gain, not just from yourself and your professors, but also from all of those around you, and figure out a way to be able to push yourself into the realms of impossible to create possibilities. I began writing a book called Disruptive Green Solutions. Okay. And this book was designed to tell the stories of inventors, CEOs, and engineers that have come up with really disruptive green solutions. And it is because of this project that I have been able to meet so many innovative thinkers. The thoughts that go into this can be as simple as a line drawing on a napkin or as intricate as a 3D modeling. But the idea is there. The thought is there. It's what I tell my children is, what is your responsibility? What is your stewardship to education, to wealth, to the blessings that you have been given? And I look at each and every one of you that are part of this, and I ask you, what is your stewardship to this education that you're receiving? I I know the things that we're looking towards within this realm of microgrids are big. You've got nanogrids and microgrids that can continue to just blanket all of the communities and businesses around the areas that you live. But again, it's thinking out of the box. I hope that I have inspired you to be able to think of different ways to create better microgrids. I challenge each and every one of you to take this and continue to push yourself. Ask different questions. Ask the questions that people are afraid to ask. And I look forward to being able to see some of you in this book, to be able to see your stories being written, to be able to see your solutions being integrated, because that is what is going to help create the society that we need. I thank you guys all for being a part of this. Thank you for the path that you have chosen and the journey that you have been on to get there. And I'm excited to see what you guys can do. Thank you so much.
Very much, Mr. Perkins, for that very insightful and informative presentation. And I might add, it was really inspiring. And now it is time for the Q&A session. I would like to tell our audience to ask any questions that you have on this regard. You can put your questions in the chat box and we will direct the questions to our speaker.
This is a good thing. No questions. Hopefully that means that I covered what needed to be covered.
I'm Rakesh here. Should I ask a question?
Please.
Yes, go ahead.
So, what about hybrid energy systems? Are you trying to go not just with PV and any other source also being added?
Pardon me? Could you repeat that? I'm sorry, you broke up.
What is the perspective of hybrid energy sources? I mean, not just PV, but integrating with other sources also like wind, biomass, and putting it together, or then depending only on one particular renewable energy. Do you have your opinion?
That's actually really important for us. You know, right now, the masses of solar microgrids are huge. That's why we started to integrate fuel cells. We have fuel cells that we're introducing that are hydrogen based. The problem with that is that there's not really a big infrastructure in the United States for hydrogen delivery. So what we're utilizing is natural gas fuel cells that have an electrolyzer in it. So it allows us to be able to convert the power into hydrogen. So there are examples of these fuel cells that have been able to not just create power, but create the hydrogen needed. And then we create the storage systems. We're literally right outside. There was a pilot that we did in Sweden that was able to create this. We've also brought in biofuel. You know, we're utilizing biofuel to power the fuel cells. Wind has been a challenge for us in many instances because there's not really any technology that is small enough to go into a residential application. Now, larger applications, we've integrated wind into microgrids quite often. There's various challenges associated with it. We actually are involved with a pilot right now utilizing wind turbine technology that is placed in the middle of streets, and they utilize the friction of the vehicles passing by to turn these, turbines that create power. But wind has always been a challenge, especially on the residential front. So the only things that we're able to utilize right now as it relates to a hybrid system is using solar, natural gas, renewable natural gas, and in some cases propane and hydrogen. But hydrogen and solar are really the only ones that give us the full potential for renewable. The other thing too is that we look at, if people look at solar as being green and they look at natural gas as being dirty. The problem that we have is that, number one, I need to create resiliency. Right? I mean, I can tell you some of my customers don't even care if I put a diesel generator. If you have somebody in your home that needs power, you don't care how you get the power, right? So when we talk about renewable energy, they say that natural gas isn't clean. Well, the problem with thinking that mindset is, if I only use solar only goes on during certain periods of the day. And California has one of the most sun in the world, but we still don't have it all. So what happens on the times when you're not using solar, if you don't have a battery, you end up tapping the grid. So now you're using dirty power from the grid, because not all power from the grid is clean, right? So now you've got transmission and distribution issues. So efficiency on a solar, on solar is 22% efficient if we're lucky. Whereas on some of these natural gas generating, systems, natural gas fuel cells and CHP, I'm running at 92, 94, 96% efficiency. And it's on site, so I don't lose any of that transmission and distribution power because it's on site. So again, people have to think outside of the box, right? They really have to understand the bigger part. You cannot just think solar is the only renewable. What else can we use, right? We need to figure out what's the ultimate goal. The ultimate goal, may be to save the planet and create renewable energy only. But in the meantime, we're damaging it because of all these things, and we're losing lives because power is not being given to us properly. Does that help?
Yeah, sure. That's a very good explanation and detailed explanation. I'll come to you on LinkedIn later on after that.
Beautiful.
We have some questions in the chat box as well. How do you convince the utilities that time of day rates are good for them?
So there's so much. I sit as a senior advisor to the California Energy Alliance, and I'm actually the one writing Title 24 policy for the state of California for demand response. So I get an insight into what's going on with policy and the time of day rates. There's so much push and pull on the usefulness and the efficacy of time of day rates. What I have seen so many proponents recommend is dynamic pricing, right? And it's hard for me to lean on any one side, because on one side they're saying time of use rates are bad. Other side they're saying time of use rates are good. But there's so many factors and variables that create a better scenario, and that's why the dynamic pricing was there. But if we don't have the ability to monitor and actually create a better metric for them to use, we're always going to be in this push and pull scenario. So it's, I hear it, I'm there in it, I'm listening to all of the feedback from the constituents within the utility space, and everybody has an argument towards and against it. So it's a difficult, it is a challenge, and I don't care where you're at, it's a challenge, because there's so many people with so many different variables that either make it better or worse, So I'm sorry, I wish I could answer that better, but it really is a difficult thing.
Thank you, sir. Another question is, 80% of EV charging is done at homes. Do you believe we'll see the installation of large energy storage sites to manage residential EV electricity demand?
So that's a really great question. We are actively doing that. So we are we're creating scenarios where we're putting in infrastructure. We're building a 5 gigawatt project for the city of California City, and the off-taker is the actual city itself. The secondary off-taker is Southern California Edison, the utility. So 5 gigawatts of power. And we're also going to be integrating this into a lot of the homes that we're dealing with. So our approach to it is put in a 1.5 kW fuel cell, or actually it was a 1 kW fuel cell in every home with solar if it's possible, because not every home wants or can put solar on their homes. So if we put in this fuel cell into it, right now it's natural gas. As we start to transition into the hydrogen economy and have a better delivery system for hydrogen, all we have to do is change out one part in these fuel cells, and then now it can actually switch over to run on hydrogen. So that's one good thing. Now, what we're doing is, instead of us putting a battery in every home, what we're doing is we're actually putting on a megawatt battery for the community. So not every community allows us to do that. So it's really interesting that you bring that up, because we literally were creating the system. We just sent out the proposal last week, I think it was. And the whole idea was put 1 megawatt batteries strategically located and create these connected communities, so that all the power, excess power that is generated by solar and fuel cells would go into this community battery, as well as be able to outflow, so that we can use this for the electric vehicles that we're dealing with. So I hope that answers your question.
Thank you for that decisive answer. Do you see limitations on utility transmission expansions creating a strong reason to growth in DER and microgrids? Do you see opportunities for microgrid growth in the backdrop of high demand forecast for electric vehicles in the future?
So it's interesting. So I'll take these two questions separately. You know, the limitations that utility transmissions, T&D, transmission and distribution, are huge, right? I mean, the infrastructures that are in place, especially here in the United States, they're so old and dilapidated that the amount of capital to improve them at an acceptable level is so immense. That's why the cost of electricity continues to rise here in California, because of their constant improvement of the system. So if we can go ahead and bring DERs into the utility space, right? And believe it or not, when people first hear that I'm in the microgrid space, they immediately used to say, wow, the utilities must hate you. And I look at them and say, the utilities love me. So you got to think about this. The utilities right now in California have to shut off the power because of wildfires. When they shut off the power, they now open themselves up to the potential for litigation because of something that happens, right? If they shut off the power and somebody dies in my house, I may be crazy enough to sue the utility because somebody died. This is a litigious society. So the utility is constantly monitoring the risk reward. Do I shut off the power and save the community? Or do I keep it on and allow potentially this whole wildfire to destroy the community? Or do I shut it off and face all of the wrath of the potential litigation that's happening? So what we do by integrating microgrids into the space is we work with the utilities. That's what everybody needs to do, is they need to look at the utilities as, how do we all work together? How do we play in the sandbox nicely together? So when we approach the utilities, we're saying, we're going to go ahead and put 1,000 microgrids in your utility space. And you can have 100% assurity that you can shut off the power and these 1,000 customers will not sue you. Why? Because they have the power that they need. They're only going to sue you because you shut off their power. So the idea that we all need to think about is, how can we work together? If we show the utilities a path to working together, can you imagine if the utility here in California, they've been shutting off these peaker plants. These peaker plants cost hundreds of millions, if not billions of dollars to build, and they only turn them on. I think it was the 3 peaker plants that they have here in Southern California only went on 3 times in the past 4 or 5 years. Okay, so they don't turn on all the time, but they're there just in case. And you spend billions of dollars on all of this capex and land that's needed for it. Can you imagine if I went ahead and created a virtual power plant in this entire community, no cost to the utility, no land acquisition by the utility? It's using the customer's homes. So now when we show the utility that this is a benefit for them, we're going to go ahead and use the utility's power when it's on and when it's cheap. And when it's not, I got my own power. And when you need power, you can take my power. So you see the relationship that we've created with the utilities. It has to be a symbiotic and a beneficial relationship. So now to answer the question, so how do I see the growth? And the reason, it's because of that. If you approach it the right way, the growth is absolutely immense, because at that point, the utilities, I'm approaching the utilities saying, hey, you're going to spend $1 billion on this peaker plant that you hope you never use. Or you can go ahead and send $100 million towards incentives and partner with the community and let us build the virtual power plants using our money and your money together, as well as using our real estate. So again, creating that opportunity for everybody to get what they're looking for. How do I see opportunities for microgrid growth because of the high demand for electric vehicles? So that is huge. I didn't even realize how big that was until recently. I was invited to CARB, the California Air Resources Board meetings, and this is huge as far as what they're looking for. And I didn't realize this, but California is not looking at electric vehicles as the future. Believe it or not, we're looking at hydrogen vehicles. And I asked the question bluntly, so why the heck are we pushing so many electric vehicles if you guys are looking at hydrogen vehicles? Because they know we don't have the hydrogen infrastructure, but they know that's where they'd like to take it. But they said electric vehicles is the bridge to get to hydrogen. And I thought that was interesting. And this is something for all of you to think about, right? Because the opportunities for the high demand for microgrids, because of electric vehicles, we need to be very thoughtful in what this means. Because I always thought the same thing that you're asking, which is electric vehicles. How do we prepare for it? We need all electric infrastructure, blah, 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 all these different things. And that's not true. We need to be able to be open to the nuances of things that we don't see. I've been in this electric state for quite some time. And it wasn't until that I sat in that meeting with CARB, the California Air Resources Board, that said, they specifically said, AJ, we're actually focused on a hydrogen transportation economy. That's where we're focused on. And I asked, are you talking about just large vehicles, right? Because right now, I think many of us can agree, hydrogen in the smaller vehicles are not real optimal. I mean, it just doesn't seem real, big in what we see as far as opportunities. Large vehicles, yes, hydrogen can work, but the smaller ones, not so much. But they're saying, we don't care. We just know once we can create the infrastructure to deliver hydrogen in an efficient and proper, safe manner, that's what we need to go towards. So these are the things that are really important as we start to do that. The growth is going to be huge for it, but we have to be very smart in how we do that. We don't want to put ourselves and pigeonhole ourselves in a position where it's just electric vehicles only. I see here another question about connected residential grids and power sharing in the microgrids. I love it. We got engaged last summer with Department of Energy, and we've got a few different pilots that we're working on with connected communities. Okay, these connected communities are instances in which they have the ability to share power. Now, I'll just be fully transparent and upfront. I don't see a lot of technologies that I trust yet. And a lot of it is just because there's so many out there, utilizing, all these different means of transferring and things. We are actively involved with being able to utilize the platform to buy and sell power off of your neighbors. And we've got 2 different pilots that we're working on, 2 different companies that we're utilizing. I still think it's new and young, so there's still a lot of opportunities for improvement. But as far as what I think it's absolutely critical to be able to make that a part of our ecosystem. So the next question, when it comes to microgrids, how about the inertia of the system? In a large grid, we can leave spinning reserves to respond in case of transient disturbances. How are such situations handled in a microgrid without affecting the customers? So we haven't had a lot of experience with the spinning reserve scenarios. because a lot of our focus has been on residential community microgrids. But what we have noticed is when we integrate our residential microgrids, it actually allows us to be shielded from some of those challenges. I definitely would like to dive a little deeper into this and try to find out from my engineers that are dealing with this how that could. So if you would, please feel free to hit me up on LinkedIn, and I can get back to you, with a real answer from my team, because I think I don't want to misinform by giving, because I have such a small knowledge on this and experience on this part because of where I sit. So, I wish I could answer better that. What microgrid controller brands are used in the markets generally? So there's a lot of microgrid controllers out there, with a host of capabilities, some good, some not so good. We have used predominantly a system called NAC or Carbon. I forget the other name of it, but NAAK is one that we've used often. They're really good. They've done a lot of installs all around the world. Currently, we have our own microgrid controller that is manufactured by Coben Genius Panel. They actually helped create our IO Hub. Our IO Hub allows us to not just use artificial intelligence to control and manage things, but it's an all-in-one smart meter, smart intelligent circuit panel, and essential loads panel all in one. And it also allows us to do so many things. But I would recommend just asking them. Thank you. Just give them your situation and see what they can do, because there's so many different things for different use cases. Like I said, the ones we use, I've gone through probably 20 or 30 different ones. And, I usually integrate them alongside our main ones just to make sure that we don't create too much disruption. But it really creates good learning. So just go out there. Like I said, the ones we use are NAC and the Coben Genius panel. Why can't you use excess energy to generate H2 as a storage on later use? So this is the thing that was interesting that we found as it relates to using energy to do this. When we bring in an electrolyzer, the electrolyzers, first of all, are really expensive, right? So the electrolyzer allows us to take the excess energy, turn it into hydrogen, right? It separates the molecules and creates hydrogen. It's a great system. I think that's the future of what we're doing. We're actually trying to create that right now in our California City project. So that is definitely a medium. If you look, I think it's I'll go ahead and find a video and I'll post it on my LinkedIn page for the hydrogen house, because the hydrogen house that was done in Sweden with our partners out of Cal State Los Angeles, the professor there went and did this pilot out there, and they did exactly that. And it's phenomenal. That house is phenomenal. So the idea is, and this was something that was interesting, I learned that utilities cannot purchase power, but they can purchase storage. So here in the United States, a lot of utilities will buy energy storage, and now they're buying hydrogen. Right? Because exactly like what you said, can we take that excess energy, turn it into hydrogen and store it? That is definitely the right way to go. But one of the challenges that we have seen, not just only in the residential side, but also in the commercial side, is the electrolyzers are high cost right now. So I think as we continue to go down this path of price compression and commercialization, it allows us to be able to get into a scenario. So we're actively involved with that. I think that's a huge opportunity for us. What else? The disadvantage or challenges of building a microgrid other than batteries for storing energy, as well as space required to store the batteries. Yeah, the disadvantages of building a microgrid, I can tell you one of the biggest ones. And not only do a lot of people talk about it, right? They talk about this, that, this, and the other. The one thing that is the biggest problem is interoperability. All of these technologies and solutions are built, right? You got solar that's built in a lab. You've got batteries that are built in a lab. You've got this, all of these widgets and solutions and technologies are built as a silo by themselves, right? The problem is they haven't created it so that they work nicely with each other. Some of these systems are also working only on a proprietary platform, which means you cannot work with other systems. And I get it, you're trying to protect your system, but that's not good for the community. That's not good for us. Because now if I go ahead and get this ABC system that only works with ABC, what if I already have this system in place? That means I have to change up all the infrastructure to put your system in. So that's where the challenges come in with creating a proprietary system. So a lot of companies now are creating scenarios where they're agnostic, right? They're technology or platform agnostic. And that right there creates a much more cohesive opportunity to bring them together. But that still doesn't take away the challenges associated with interoperability. I'll tell you a story. I was brought into a consulting scenario for a large solar entity, a large solar EPC here in California. And excuse me, they had installed over 1,000 solar plus storage installations here in California on homes. That's huge. That's a lot. Okay. What they found out was that they had a 50% failure rate. They had 15 technicians inside of their office answering calls, and they had 50 technicians out on the field answering these calls. If I installed 1,000 systems with a 50% failure rate, I would get fired. But when I went out there and looked at it, they used top rate, they used, tier 1 solar. They were using Canadian solar, good batteries. They were using Tesla or LG batteries. They used good control systems. Everything was good products. They were a great EPC. They know how to install, so it wasn't their fault. It was interoperability. It was the ability for these pieces of equipment to work nicely together. So when you ask what are the challenges of building a microgrid, this is a statement that may be heard out in the microgrid world. If you've seen one microgrid, you've seen one microgrid. It's a play off of the term. If you've seen one car, you've seen them all. Well, that's not true in the microgrid world. If you've seen one microgrid, you've only seen one microgrid. But that shouldn't be the case. I think because we all know whenever we build one-offs or customize, it's so expensive. The goal is to be able to create a plug and play where you just pick and choose and just put them all in. But we can't do that in our perfect world all the time. Okay. So I hope that answers your question. My email address is aj@instanton.energy. So our website is instanton.energy. And if you just go ahead and put AJ in front of it, that's my email address. And again, if you want feel free to connect with me on LinkedIn, and I'd be happy to chat. Can you explain the influence, the electric vehicle to grid scheme on the stability of the microgrid? So electric vehicle integration with the microgrid and being able to do V2G, right? V2G allows not just grid to vehicle, but also vehicle to grid, and that exchange of power. What that does is it on that side, the ability to use a smaller battery, be able to create a better system, but we just need to make sure that we can control loads, right? So I think that's where a better microgrid control system is going to be really important. Do you want me? I know that time is running short. I want to be mindful of it. Would you like me to continue answering the questions, or would we like to create an offline scenario where people can reach out to me directly?
Yes, actually, we are constrained by time. So
Sure.
I think anyone who has questions can send them via the LinkedIn profile. We have embedded the link to the LinkedIn profile of Mr. Perkins to the emails that we've sent you. So I think you can contact him at any time and ask your questions, ask any concerns that you have. As you can see, he is willing to answer any question you have. And thank you very much for being a very enthusiastic audience. And shall we take a group picture? If you can turn on your cameras, if you don't mind, so we can have a picture with Mr. Perkins. So thank you. So we will be taking the screenshots right now. You have been a great audience, and from your questions, we realized how useful this session for you were. So thank you for paying attention, and thank you for learning, and we hope you learned something. And it's really nice to see you all. Okay, I hope the pictures are being taken right now. We have an audience from all around the world, so I think this was a very, very useful session for all of them. Okay, while the pictures are being taken, I would like to thank Mr. Perkins, and also we will be giving a virtual appreciation, token of appreciation to Mr. Perkins for his immense support and his insights on residential microgrids. Thank you very much for sharing your knowledge with us. And since that we can't do anything physically, we are doing everything virtually now. Even the tokens of appreciations are virtual. So, but that has actually connected us since, even though that we are very far away. So now, in order to deliver the vote of thanks, I would like to invite the Assistant Secretary of IESL Young Members Sectional Committee, Electrical Engineer at Ceylon Electricity Board, Ms. Zara Marzouk. Over to you.
Good evening, everyone. I am Zara Marzouk, and it is with great pleasure that I present the vote of thanks for today's webinar on residential microgrids. I would like to thank our guest webinar speaker, Mr. A.J. Perkins, President of Instant On, for visiting us virtually and enlightening us. Today's webinar was full of technical know-how and interesting aspects. It gave us deep insight into the topic and also revealed some interesting aspects. How you focused on people, Mr. Perkins. And the opening where you talked about the impact of wildfire, it was eye-opening. And I'm pretty sure this precious knowledge you shared with us within this small amount of time will definitely help us with our future research and study on the topic. Take home message through your lecture, along with that vast ocean of knowledge in the slot of less than 1 hour. When I was listening to a lecture, I was reminded of something that Dr. Albert Einstein said that education is not the learning of fact. Is that came across my mind. So you have no doubt inspired all of us today. I, for one, I'm eagerly looking forward to read your book, Disruptive Green Solutions. I hope it will be soon published. And also your way of answering the questions that are thrown at you was very energetic. We enjoyed it very much. And I would like to thank you much, Mr. Perkins. Thank you so much. Department of Electrical Engineering, from Learn Zoom. Without it, we wouldn't be able to host this webinar with the participation of nearly about 150 participants. I would also like to extend my special gratitude to Professor Udayanka Hemapala of Department of Electrical Engineering, University of Moratuwa, for being a pillar of support as the advisor to the IEEE Power Electronics Society of University of Moratuwa. My heartfelt thanks go to IEEE Power Electric Society of University of Moratuwa for organizing this event and for their tremendous effort to raise awareness on the next generation technologies of reliable connectivity for and young member sectional committee of the Institution of Engineers Sri Lanka. A huge thank you to the young member sectional committee of IE coordinated the participation and arranging to share about this event among the young engineers. Also, thank you Institute of Engineers Sri Lanka for emailing all the members and educating regarding this event. Last but not least, I would like to thank all the participants today for being so supportive to the organization of Microgrids. You all helped us make this webinar a tremendous success.
Thank you, Ms. Sarah. We have come to the end of yet another valuable webinar. Hope you all learned something new and enhanced your knowledge. Thank you for being a great audience. Let's meet again in another Tech Talk very soon. Until then, stay safe. Have a nice day.